What are the functions of data engineering? Data engineering consists of five functions, namely acquisition, transport, storage, processing, and serving. Data pipelines are built by combining multiple such functions to deliver a given outcome. Let's start with data acquisition. The goal of data acquisition is to extract or receive data from a data source and publish it into a big data pipeline. While acquiring data, the focus is on understanding the format of the source data and converting them into formats suitable for downstream processing. We work with interfaces provided by the source systems to extract data. Alternatively, we can expose interfaces through which clients can publish data into the pipeline. Security is also a major concern, especially if the data sources are not within the trust domain. Reliability of data is of importance, especially when acquiring from remote sources. Finally, latency is also a consideration for streaming data analytics. Data transport deals with moving data within the pipeline to various processing and storage endpoints. Data transport should be reliable and should maintain the integrity of transported data. Transport requires scale to deal with large quantities of data in the big data world. Data security and privacy may also be key concerns. Latency is an important transport consideration for real time use cases. Finally, transport should also be cost effective. Then comes data storage. While designing storage for big data pipelines, a key requirement is the flexibility of data as new use cases and requirements will constantly emerge when the system grows. Schema design needs to consider this. Popular query patterns should be considered while designing the schema. Storage should also provide for high availability and redundancy to ensure resilient operations. Finally, the choice of technology should also be cost effective. Data processing is the next key function. Common requirements like scale, resiliency, latency, and security also apply to data processing. In addition, data processing should provide capabilities for cleansing, filtering, and enriching data with additional features. Data should also be aggregated in cost effective operations. Machine learning can be part of data processing operations in real time prediction use cases. Finally, data serving is also an important function. Serving can be done by either exposing APIs and interfaces or by pushing data to endpoints for downstream analytics. In any case, requirements around latency, high availability, and security also need to be considered. Skill levels of consumers should be taken into account while exposing interfaces. The schema of the data should also be flexible to provide for multiple use cases and popular query patterns.